Hello everyone. So today let's solve the problem number 54, spiral matrix, right? So I'll just read out the question loud. Just listen to this. We have been given an m into n matrix. See here, we are given an m into n matrix, right? So here, so we have to output all the elements in the spiral order, right? So we have to output all its elements in the spiral order or the clockwise, right? Starting from the top left and moving right, then down, then left, then up, right? See here, that's what they have given here. One, right, then down, then left, then up, then right. So see here, 1 2 3, the output that we need to get for this one is 6 9 8 7 4 5. They have given us wonderful diagram just for the sake of understanding, right? Here, see, 1 2 3 4 5 6 7 8 9, we have this one rows, 1 2 3 4 5 6 7 8 9, 3 rows. We have 3 into 3 matrix, right? 3 into 3 grid, this one, right? So we have to get the output in the spiral order in the sense. See here, this one, 1 2 3 6 9, arrow mark they have strictly mentioned 9 8 7 4 and 5, right? So this is fine, I believe, right? So we have given an m into n matrix. We have to output all its elements in the spiral order. I have shown you the spiral order. See, same goes with the example 2 as well. We have 1 2 3 4, this one, 4 into 4, 4 into 3, right? So or 3 into 4, sorry. So this one, 1 2 3 4 5 6 7 8 9 10 11 12 we have. So this one, 1 2 3 4 8 12 followed by 11 10 9 5 6 and 7. So this is the output that we need to get here. And one more thing, we have to flatten the matrix as well. See here, we have been given different this one, right? So within the array, the 3 arrays we have here, right? So nested arrays. So we have to display this one in the single array, the output. That one also we have to keep in mind, right? So let's discuss the approach followed by the complexities, and then let's write the code, right? So first let's discuss the approach. So first thing is, we'll be going with a math or geometric approach, simple math or geometry approach, right? Just keep this in mind, right? So this is fine. First thing here is, we'll be treating the matrix as rectangle with the 4 boundaries, nothing but here in our case we will be considering top, bottom, this one left and right here. So for the top and this one left, for the top and left we will be initializing this one with a 0, and for the bottom and right we'll be initializing this one with a 2. Just remember this one, right? So this is fine. Now we will traverse the top row left to right, right? So we will add 1 2 3, then we will move top down to 1. So this one we have considered. Just give me a second here, 1 second. So this is fine, I believe, whatever I have explained, right? So till now, so I'll just come here. See here, first example we have considered here. First what we will do, we will we have assigned this one. Let me write this one again. Top, this one, bottom, left and right, right? So we'll initialize top and left to 0 and bottom and right to 2 basically. This is fine. So I have said the same thing, don't get confused here. So then we'll traverse the top row from left to right. So we'll add 1 2 3, then we will move top down to 1. See here, we will go like this, 1 2 3, then what we'll do, we'll move top down to 1, then we will traverse the right column, right? So top to bottom. So this one will be basically 6, then we are traversing top to bottom, right? So then we are traversing the this one right column, nothing but from top to bottom we have added 6 and 9, right? So then we will move right left to 1, then we will move right, this one, right, this one, right left to 1 basically. Now we will traverse the bottom row right to left, meaning we will be adding, now we have went from this direction, now we are moving 1 step ahead, this one, right? So right to left 1 step, so this is nothing but we'll be adding 8 and 7 here. This is fine. Now what we will do, we'll traverse the left column bottom top, so we'll just add 4, then we will move left right to 1, right? Now rectangle will be single, meaning we'll just add 4 here, this one to this one, as we had already considered this one 1 and we have marked this one. This is fine. Now we will add this one 4, right? So now what we'll do, then we will move left right to 1, right? So now we will go with cell top equals 1, left equals 1, bottom equals 1 and right equals 1, right? So now this one will be top 1, this one bottom 1 and so this is nothing but the arrow mark, don't get confused here. This is nothing but the left 1 and this is nothing but the right 1. This is fine, and this is fine. Yep, now we'll traverse the top row, so we will be adding 5, right? So we'll traverse the top row, so now we will be adding 1, this one, adding 5, sorry, right? So this one will add 5 finally. So now we are done with the elements, right? So everything is marked, basically whatever row we have visited. So this one is visited, marked, this one is fine, this one is fine, and finally this one. Now we are done. So basically let's discuss the geometric view here. So each loop, what it does, it peels one perimeter layer of the rectangle, basically shrinking the boundaries until they cross, right? So this is basically the geometric view in simple terms, right? So this is how we got the output. See here, this one we are displaying output, right? So this one we are displaying here as the output. See, the output that we got here is 1 2 3 6 9 8 7 4 5, which is equivalent to the output that they have mentioned for the example 1 within the question. Simple, right? So we are done with the problem, right? So this is the approach that we'll be following basically. As we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So what will be the time complexity? So this is m into n grade, right? So overall time complexity would lead to big of m into n. So we are visiting every cell exactly once in the traversal that I showed you, right? So we are visiting every cell, every cell is visited exactly once in the traversal. So overall time complexity would lead to big of m into n. So what would be the space complexity here? The space complexity would lead to big of 1, because this one output list requires big of m into n space, right? But we are going with the extra this one that is beyond the output, nothing but big of 1 here, right? So this one, the space complexity would lead to big of 1. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of m into n and big of 1 respectively, right? So as we are completely familiar with the approach and the complexities, let's start writing the code. First step, so we have to go with the result list just to collect the spiral order. So I'll just go with the array list here. So let's go with integer result. Let me assign this one to the new array list. So this is fine. Yep, this is also fine. Now let's do one thing. We have to go with the empty check. We have to return the empty list if nothing, right? So this is fine. Let's go with the simple if condition. Suppose if matrix is null or matrix dot length, so this is equivalent to 0, then what we'll do, we'll return result. So this is fine. The next step is we have to go with the number of rows and we have to go with the number of columns. In the sense, I'll just go with int m equals matrix dot length, gth length. This is fine. Also we have to go with the number of columns. Let's assume at least one row, right? So int n equals matrix of 0, this one dot length. So this is also fine, I believe, right? So next, let's move on with the next step. Let's move on with the further steps. So first let's go with the top boundary. Let's start as the first row. Basically it starts as the first row, starts as last row, starts at first column and starts at last column, nothing but top, bottom, left and right respectively. I'm speaking of, right? Top boundary, bottom boundary, left boundary and the right boundary. Top will be initializing to 0, bottom m-1, left to 0 and right n-1. Starts at first index, starts at last index, left starts at the first column, right starts at the last column respectively, right? Let me go with int top equals 0 here and bottom equals m-1. This is fine. Int left equals 0 and also int right equals this one. Let me go with n-1. This is also fine. So now let's do one thing. We have to loop until boundaries cross. We know this one, right? So let's go with the or we have to consider every iteration we traverse one outer parameter, right? So for that, top has to be less than or equal to bottom and left has to be less than or equal to right at any cost, right? So that one, let's mention that one in the while loop. So this one, top less than or equal to bottom and left less than or equal to right. This is fine. So within the while loop, let's do one thing. Let's traverse the top row from left to right. So let me go with the for loop here. So this one will be for int j equals left, j less than or equal to right. So this is also fine, j plus plus. So this is fine, man. Let's add the element at top comma j. So this one will be result dot add. In simple terms, I'll just go with the matrix of top. This one is fine, j as well. So let's add the element at top comma j. That's what we have done here. So this is fine. Let me come out of this one entirely. Let's increment the top. So this is also fine. Let's do one thing now. Let's traverse the right column from top to bottom, right? So we'll be traversing the right column from top to bottom. So also we have to traverse bottom row as well. So we'll be traversing everything. So 4 steps we have to go with, right? So first right, then this one, top to this one, bottom right one. Finally last column we have to traverse this part. I'm speaking of this one. Then from the last column, this one, from right to left we have to, then to up, then again the last one is we have to traverse one step right. So for this particular this one I'm explaining. First what we did, yep, just give me a second here. We have traversed top row from left to right. Now we have to traverse right column from top to bottom. So again one more for loop here. This one, let me copy the same thing here and make the necessary changes over here. So this one has to be for let this one, instead I'll just consider I here. Instead of left, let me go with the top. So this one, I less than or equal to bottom. So this one has to be bottom, and let me go with I plus plus. So this is fine. So this one will be result dot add of matrix of I and right. Simple, I and right. This is fine. And this one has to be right, minus minus. This is fine. So we are just moving the right boundary left after visiting the right column. This is fine, man. Next, let's do one thing. I'll just go with one more for loop here, or let me type this one entirely, as we'll be going with a only if condition rather than the loop. Loop we have to go at anyways. So this one again will be traversing bottom row if there remains a row between top and bottom, right? So that's what we need to do. So this one, if top left than or equal to bottom. So this one, let me write the for loop again. So this one has to be j equals, let me copy this one entirely. So let's do one thing, or what should I do here? So yeah, let me copy paste this one here. So this one, instead of the left, this will be right, j equals right, j less than, greater than or equal to left, basically equal to left. And this one, instead of the, we are reverse iterating, right, from right to left, basically this has to be j minus minus, right? So this part, 9 to 8, 8 to 7, basically this part. Result dot add, this is fine. Matrix of this one has to be bottom, not the top this time. So previously we had went from top to bottom. Now we are considering bottom itself. This has to be bottom of j, basically bottom and j, basically this is fine, right? So we are just adding the element at bottom comma j. So this is fine. Finally what we are doing, so we will move the bottom boundary up after visiting the bottom row. So let's do one thing. Let's decrement the bottom here. This is fine. We have just decremented the bottom. So we are just moving the bottom boundary up after visiting the bottom row. So this is fine, man. Let's do one thing. Let's move on with the final step. So we have to traverse only the left column if there remains a column between left and right, basically this will be the last step, meaning we have to traverse left column from bottom to top, basically, right? So how can we do that, basically? So let me write one more if condition here. If left less than or equal to right, so within the if condition, so let me go with for loop. This time let me type. So this one will be int I equals bottom I greater than or equal to top, so this one will be we have to decrement, right? So we are moving from bottom to top, not from top to bottom. Basically this is fine. Now let's add the element at I comma left. In simple terms we'll be going with result dot add of let me go with a matrix of this one I and also left. This is fine, I believe, man. Finally let's do one thing. Let's move the left boundary right after visiting the left column, meaning left plus plus. So this one last part we have to, if their element exists here within the center, right? So this one we are moving from 4 to 5, the last step, right? So from 4 to 5, this one also we have to consider. So incrementing the left has to be we have to do that's the necessary step, right? So we are moving the left boundary right after visiting the left column. This is fine. Finally we have to return the spiral order, so we are saving that one in the result variable res, I believe. Consider res. No, wait, just give me a second here. One second. So where I have so yeah, this one. So done. Sorry. Yep. Let me come here. We have to return result. We are storing in the result variable areas, right? So let me hit the result button. I mean, sorry, run button. The result. We are getting the wrong answer. 1 2 3 6 9 4 5 8 7. Expected 4 5 has to be at the end, correct? We are getting 8 4 5 first and then 8 7. Just give me a sec. So I have misplaced the bracket, I think. So here I have closed the while loop here itself, I like this one if condition and these two if condition has to be within the while loop itself. So I have to place this one, what do you call, bracket here, I believe. So that was the wrong thing. That is the reason we are getting the output at the end. So this part we have to get at the end rather than this one we are getting at the first itself. So let me run this one. Now we have to get the correct answer. Let's see. Yeah, yep. That was the main problem actually. The sample test cases are getting passed. So let me hit the submit button quickly. So I hope this works for all the test cases, man. All we have to do is write the code for moving this one in the spiral order, right? So from what order we have to move, that we have to know. That is the reason we have went with 2 if conditions and this one and a while loop and 2 for loops, 4 for loops, right? So this one for moving basically from left to right, then this one top to bottom, then from right to left, then from bottom to top, then finally we are moving inwards basically towards the center, right? So that is the order that we need to keep in the mind. So this is very simple, man, right? So this is fine. Yeah, all the test cases are getting passed here, meaning whatever the code that we have written works absolutely correct for all the test cases, right? So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.